I've assembled a complete but not final version of my 7-axis robot arm. It's controlled with the PS3 controller. The right analog stick controls the wrist joint and the base slew. The left analog stick controls the shoulder and elbow joints. The D-pad controls the smaller wrist motors, and the trigger fingers control the gripper. I'm no expert at computer games, and the control system can be a little bit unintuitive. On certain angles it is easy to control, and on other angles it's difficult because of the orientation of the joints relative to the particular viewpoint. With the D-pad controls, I find myself always turning it the wrong way first or choosing the wrong motor first. So you'll see quite a few little jitters back and forth as I struggle to control it. Lifting to the plate to the horizontal here requires a considerable amount of torque, more than the little AX12 wrist motors can handle. But due to the redundancy of the 3-axis orientation, the smaller motors can be aligned so that they aren't fighting against gravity, and the power lifting can be done by the single smaller linear actuator. This can generally be achieved in most orientations. I'm still a little bit undecided about the geometry of the arm. You can see that I've shortened the forearm by attaching it to the shoulder joint halfway up. I haven't cut the end off yet because I still might try a different length. The current system shown here allows the objects to be manipulated close to the arm base, and as the forearm gets extended, it gets a longer reach and can pick up objects below the level of the table, but it does mean that it's more difficult to manipulate objects as they get closer in. Originally, I had the wrist linear actuator on top of the forearm. However, this would get in the way when the gripper was in an extended position. Moving it to underneath still has some issues, but ultimately the problem lies in the fact that the wrist position is geared to the position of the linear actuator in order to increase the range of movement. However, this means that as the actuator is extended, the wrist moves towards the actuator, and therefore they start to get in each other's way, as we can see here. The solution to this is to use a timing belt so that they move in opposite directions and then would no longer clash. I almost stuffed up this final piece of manipulation here because the gripper can't actually open wide enough to go over the top of this cup. What I should have done is simply drop the gripper down at this point here, but instead I tried to lift it up before realizing I can't do that, dropping back down and backing out. Generally, I'm really happy with how the gripper's performed. It seems to have a lot of analog intelligence between the compliance in the arm itself and the differential in the gripper. It seems that it can latch on and pick up almost any object without too much effort. Ultimately, I'd like to fully automate this system with computer vision or similar technology. I can attribute some of the poor performance of this manipulation run to the operator, and my only excuse is that I'm trying to establish a low baseline so that I can get superhuman performance with an automated system. The next steps in development are to tweak the wrist geometry and perhaps look at the base where it's attached. Originally I was thinking about using a mobile platform, but after going through this demonstration I think I can achieve quite a bit from this stationary position. I now believe this low-cost robot arm has the power and dexterity to perform meaningful tasks, and look forward to automating it in the future.